Okay, so without causing further delay, let me start this faculty masterclass or webinar in which we talk about data science, machine learning, deep learning, generative AI, and general data analytics in big data supercomputing perspective, such as applied in businesses. And as we say, that IT and data science is essentially eating the world. What it actually means is that whatever traditional businesses we had earlier, if you do not put a cream or a layer of IT and data science coupled together, then you are bound to fall. Your business is bound to fail. So that is where we at Abioteq bring in the acceleration of data science and technology. We apply it with Internet of Things, for example. We also apply cloud computing, supercomputing, and many such similar technologies which are needed for this kind of world. So this is the website abioteq.net. You can reach out to us and let us start by telling more about it. So this is our mission to promote data science, artificial intelligence and machine learning, and of course the Internet of Things technology, or which is also commonly called as robotics. So this is our team. We have Mr. Janmijay Singh. He was the founder of a company called Tantrabyte, which lasted for at least 5 years. And finally, he had to sell off, but he did pretty well for that company. And now he's collaborating with our company called Abioteq, in which I am the founder. And I'm also professor at a German university called, well, its head office is actually in America, in the US. And it's called Schiller University. And my background is that I've done MS in computer science, data science, and statistics, and biomedicine as well. And I previously was an IIT, I was an IIT student, and now I'm an IIT graduate from IIT Delhi, and where I also did my MTech. And I submitted a version of my PhD thesis at Cambridge University, UK, and also in the mathematics department and computer science department of Leipzig University in Germany. I submitted another thesis, and I submitted also one thesis at Mississippi State University in the US, and also one thesis in India. And I have an MBA as well from HHL Leipzig, the program partnered with Harvard and MIT and the US universities in Boston. And with these, we have other players from abroad as well in Europe and America who are collaborating with our team. And let's dive deeper into what is data science. So the simplest thing that comes to our mind when we think about data is that, okay, we need to fit the sample data or the known data by some kind of a line. This is what typically people do in their college education, such as in the first or second year in engineering or in science or in business. This is what we try to fit a line and see which one fits the best in terms of the least of the noises. There's R squared terminology and many other things. But this thing actually works very well if the data is known. We have a gut feeling, or you know that the process is going to be linearly related. But if things are not linearly related, then you will probably need a curvilinear or polynomial fit, polynomial regression. There are transformations that are needed for that. And as you can see how the line is moving and what fits the best is being fitted over there. But that is a lot of work. I mean, I'm not saying I'm not against linear regression. That's a good thing to start with, especially if you can do multi-nomial and polynomial regression fitting, transformations and stuff like that. But now with data science, there are like different kinds of better things like logistic regression, where you have the known values, you train it on a known values, use a ReLU or a trig-modal function, such as over here, fit in the parameters and see which one fits the best to categorize. There could be multi-levels of logistic regressions. Just one, if you have two categories, you just use a single logistic regression, but there could be many categories, and then there could be multi-levels of logistic regression, such as this. So this is not a straight line, but it is some kind of a regression. And the sigmoidal function, the ReLU function. We use which one suits our situation depending on this. And similarly, we have a probate regression as well when we talk about population of data. So what is now more interesting is that we had something called perceptron, which used to do some kind of XOR gate filtration. And then if you combine them in certain combination, you can train them whether with given certain weights, you can train whether a certain input was an apple, a banana, an orange, strawberry, or any other fruit, or just fruit, but it can, this is just an example, it could be any other thing. And once you've trained it on known data, the weights are so good they are calculated, and then you can use it for unknown data for that purpose. So this is how it works, but in a more better sense. Say, for example, if you want to have numbers, because people have different ways of writing how a number could look. Okay, so the number could be 7, 8, 4, or it could be a child who is writing it, or an adult, or an old person. So they all write it differently. And if you have trained on a different set of data where the ground reality is well known, then what you would do is that you would then see how good your specificity or sensitivity or those confusion matrix and all the other things are. What is the loss function and many other things. There are a lot of terminology that has been built up in this world of machine learning and deep learning or data science in general. As you can see in convolution network, we kind of use different boxes and then look at the numbers in each of the boxes and try to rotate it and then do some manipulation, such as take the maximum of all the boxes or the minimum or the average, and then we repeat it. So and then that value is then scored over there. And this kind of thing is typically very good for pictographic situation where you have pictures. It's very good. It has been proven to be very good. And this is actually, it works. So you have trained it on these data. There are a lot of neural network layers in the background where you convolute, you do it repeatedly, and then once you've trained it, you use it. So machine learning is essentially a simple tool. There could be many other methods like such as support vector machine. There could be, as I told you, logistic regression already. There could be, perceptron methods. There could be many such similar methods, such as decision tree or similar such things, where you have input, there's an output, you kind of rotate it to improvise your model, and then use it, and then after a while you train your model again if something drastically changes. For example, in finance, you have built a model whether the occurrence of an event leads to the rise of the price of the share or not, and so you can already have a prediction, especially in the long run cases, long-term investments. Short-term as well, people use it, but then short-term is you have to really act quickly. So there could be spam detection, for example. Email, you have a sender, you have already set that, okay, these kind of emails where you get that, okay, take drugs, give us some money and all these things, you have already put them as spam. And then obviously the machine learns that, okay, you do not want such kind of emails anymore. And then the spam, most of the such emails can be put in the junk folder automatically. And then it's your job to once in a while go to the junk folder and see whether that email was actually spam. And fraud detection model as well. For example, you have the customer information, his spending history, ongoing transactions, and then from that you can predict what is the possibility that the person is actually trying to, whether he has a history, even if he doesn't have a history of doing fraud, what is the possibility that he can commit a fraud, right? And you will get certain confidence for that, right? And as this webinar will touch upon a little bit of bioinformatics stuff as well. So I bring my own paper, which I wrote when I was at Schiller University. The tool that I developed, or the method that I developed was called DMWAS, where I used deep learning, machine learning, omics-wide association studies, typically genomic-wide association studied, which was inspired from GWAS, which is very well known in biomedical industry, where using deep learning, machine learning methods, we were able to find out certain markers in the DNA, which can make a person prone to certain kind of disease or death, such as from heart. And we took real data. This is the GTEx data that was taken, and we could find out real markers or genotype, as you call it, the position in the chromosome and the variants, and this is it, and what it is actually given an ID or not, and what is the probability score, and all the column numbers and the row numbers and all things. So if you have, say, for example, 10 of these probability score, which cumulatively added up, there's also called something called a cumulative distribution. So if cumulatively you reach like a rheostat, you built upon certain possibility of getting disease, such as the heart disease. Cumulatively having such biomarkers, which might not be just like hundreds of them, but if cumulatively, then you get a good score of becoming prone to a disease, then you can go into the problems with that. So yeah, let's talk about decision trees. What are decision trees? What are terminology in decision trees, data splitting criteria and decision trees? And here it is, for example, a homeowner, where we can say whether it's good or bad in terms of his credit rating, if we know we are good or not. If no, then his marital status, single, divorce. If married, then we have a good possibility of he being good. In terms of credit rating and so on and so forth, you can have bad things. So based on these kind of decisions, you can decide whether to give someone some loan credit or not. And here's an example. So you can split the data in different ways, and then you can have more of plus the kind of people whom you like, and minus the kind of people you don't like based on certain criteria. For example, 5.5 is the height of people who love, for example, cricket, or there could be some other criteria. So you based on these criteria, you can see by which, how, and what, by what number splitting gives a best, what I would say is fragmentation, or I would say segregation of data. That makes a lot of sense, and you can repeat it to come up with a pure node or homogeneous node, as much node as possible. And there is a lot of mathematics involved in it. There's concept of root node and leaf terminology, branch, and all these things, which we will teach you if you take a course. But what is important is that there are mathematics like Gini impurity, entropy, information gain, chi-square, which is needed for these things which we teach in our course. And there is a great demand for data science in coming years, as you can see, and that is why we are launching a program called PGP DDS, which is a 6 months program, and we teach you game theory, Python, SQL, NoSQL, and many other things like deep learning, advanced learning, shell scripting, data structures, algorithms, and mathematics of algorithmic data analysis, and all these things. And these courses typically cost you more than 15 lakhs if you go to a university. And we have currently offered you for about only 90,000 INR with the certification. If you don't like to do a whole 6 month program, which will start in February and end of February and last till beginning of September, here's a timeline. Then we also have shorter 3 month duration courses, which you can avail if you want bioinformatics, for example. You go for bioinformatics data science program, or robotics program we have coupled with AI, such as for bioreactors, fermenters, mechanical devices, and many other things. And if you are only interested in managing, we also have a management information system course. But what I recommend is the starter thing called the algorithmic data analysis analyst program, or bioinformatics data scientist program, which would be very suitable to anybody. So game theory and decision, as an example, you can have information, which can have complete information or incomplete information, and the situation could be static or dynamic. This is how it looks like. We try to teach Nash equilibrium cases in static and complete information situation in our courses. And we also try to teach Bayesian Nash equilibrium, which has Bayesian statistics based on that. We don't touch much on the dynamic part of at this point, but here are the situation. For example, a prisoner's dilemma, as an example. You have a dominant situation where people will confess, because if he confesses, he will get -1 and -5, which is much less than if he doesn't confess, -2 and -10. So this person confesses as well, he will get -1 and -5. If he doesn't confess, he will get -2 and -10, which is worst case. So both people confess and they end up getting -5 and -5 as a penalty compared to what could have been the optimal solution. So these kind of concepts of game theory is also there. And there are concepts of backward induction, where we teach the games starts from the back, seeing the profit or the payoff from the last game, and then move upwards to come to the optimal solution. So generative AI is essentially a part of the deep learning process, and we teach a part of that in our program as well. And this is very known to improve productivity of employees to a great extent. So that's it from me. If you have any questions, then we just finished this short webinar quickly. Otherwise, I'll look at the chat. If anybody has any question, they can write to me, or you can also speak up. Thank you.